Yeah, I mean, I started setting up. Yeah. Do that.
Yeah. I think so. The circuits. Show me.
Hello, Professor. How are you?
I'm fine. I'm waiting for others to join. We are just 5. So we'll give them a few more minutes.
Sounds good. No worries. Do you have any weekend plans?
Grading.
That doesn't sound too fun.
Used to it.
So you're gonna watch the World Cup and watch Mohamed Salah play?
Pardon me?
Are you going to watch the World Cup for soccer in Qatar and watch
No.
Mohamed Salah play?
No, I am not a big fan of soccer. I'm not athletic.
Why not, Professor?
Lazy duck.
Oh, that's okay.
Okay. I think we are going to start now. I'll share the screen. Half adder. In half adder, we mean that I am going to add just two numbers. I know that 0 added to 0, I will get 0. Output, the summation is 0, and no carry. 1, 0, it is 1 with no carry. 0, 1 will be 1 with no carry. But 1 added to 1, this will be 2. So I am jumping from my current digit to a higher digit in binary. First digit, second digit, third digit, and so on. The first digit, it is 2 to the power 0. And this is 2 to the power 1, 2 to the power 2. So 1 plus 1, it is 2. So it is equivalent to 2 to the power 1. So it will be 1. And here I put 0. How we can implement this? If I look at this table, I can see C out will be 1 only if A and B are high. Isn't that an AND gate? A and B feeding an AND gate. This is C out, A and B. What about the summation? This is the carry, and this is the summation. Either one, A or B, is high, I will get high. This is a typical exclusive OR, this circle. This is exclusive OR, the summation, and the carry will be just an AND gate. To build a half adder, I build it out of AND and exclusive OR. If I want to build half adder using VHDL, I'm going to use this. What about full adder? Full adder is different from half adder. Full adder, I can get carry from previous stage. This is just the input A and B. What about if I have a previous stage, a lower stage? Suppose that this is feeding the next stage. I will have A and B and carry from the previous stage. This is called full adder. Let's see how it works. Now I have 3 inputs. If all inputs 0, I get output 0, no carry. If I get 1 input is high, I get 1. If I get 1 and 1, I will get 0 as we saw before, and 1 will be carry. If I have any 2, 1, 1, I'll get 0 and carry, 0 and carry. What about if I have 3 ones? 3 ones means what? 2 to the power 0, 2 to the power 1, and 2 to the power 2. This will be 1 plus 2 plus 4, that is 6. 6, we can have this 6. how we get it? 1 and 1, it is 0 and 1. And the third one will come in here into the summation. The circuit for this one, I have the first AB with no carry. This is the initial stage. We know the summation, it is A exclusive or B. Now I have Cin coming to the second stage, in addition to the result of the summation. How will I do it? According to this truth table, if I have C of the first stage, the carry of the first stage and the carry of the second stage, if either one of them is high, I will get my carry high. This is an OR circuit. So I'm getting here for this summation, I get carry in and this exclusive OR. Carry in, exclusive OR, the exclusive OR before it. And for C out, I am getting what? As I did before, I am getting for this C out the AND of those two. Those are ANDed, and now my final carry will be an OR gate. This one or this one. That is how I built a full adder. And please note, I built it out of 2 half adders. I used 2 half adders to build the full adder in addition to an OR gate. And the full adder, it is AB plus C carry from the previous stage. Let's try it. Cameron?
Yes.
Now we know the truth table, this table. If everything is 0, I get 0. If one of them is 1, just 1, I will get summation 1 with no carry. If I get 2, any 2, A, B, or carry in, if any 2 is 1, I will get 0 and the carry will be 1. If I get 3 high, I will get 1, 1. According to this, what do we expect the summation and the carry out?
The carry would be 1 and the sum would be 0.
Excellent, excellent. That's it. Yes. And this question here, Chad? Hello, Chad.
Yes, sir.
This one here, it is saying the previous example, this is the inputs A1, B0, and C out. This is the third one. It was 1. So the result with that will be 0, 1, as we did. Now, if I tell you that this is a full adder, what will be the result of A?
It would be C out would be 0, And the summation would be 1.
Excellent. Thank you. Jose? Hello, Jose?
Yes.
Number B, please.
Where would you like me to do B?
Yes, B. Thank you. Do you have this PowerPoint?
Yes, I can see it.
Okay, you can go to the truth table and see it.
Let me go check it out.
Okay.
I can't find the PowerPoint.
You can't find the table.
No.
Isn't this the table?
Yes.
Okay, you can find it then.
Okay. Let me see. Will that be 0, 1?
Yes, it will be 0, 1. Thank you. What will happen if I need to add one number that is a 4-bit to another number B that is another 4-bit? 4-bit plus 4-bit. The way to do it is I am adding the smallest 2 bits, and if there is carry, it will come in here. And I will get a summation and a carry. Now I am going to the higher 2-bit, but here please note that the carry of the first stage is feeding the second stage. That is what we said. We said I'm going to get carry from the previous stage, the smaller stage. So C1 will feed as a carry in. C out 1 will be C in of stage 2. I am adding A2, B2, and C in, which is C out 1. And I will repeat that C out 2 will be the carry in of stage 3. The carry of stage 3 will be the carry in for the last stage. At the end, I will have 4 summation and 1 carry. 4 summations and 1 carry. From the input side, I am adding 4 A's and 4 B's and the initial carry. So from the input side, I have 8 plus 1, 9, 8 plus 1, 9. And on the output side, I am getting 4 plus 1 carry, that is 5. We are going to see how we may do the VHDL program. Of course, this method, I will not be able to find the last stage until the carry of the first stage processed and the carry of the second stage processed and the carry of the third stage is processed. This is a time delay, but will not worry about it at the moment. Now we are going to see this example. Vitaly,
Yes, Professor.
I have for the first stage no carry.
Okay.
And I have now the input 1 and 1.
Okay.
What will be the summation?
The summation will be 0, but your output carry will be 1.
Okay, now I have this one coming in here.
Okay.
1, 1, 0. What will be the result?
Again, the sum will be 0, but your output carry will be 1.
And this one will come in here. Now I
Yes.
have 1, 0, 1. What will it be?
Same thing. Summation will be 0, carry will be 1.
So my answer will be 0, 1, 0, 0, 1. 0.
I see. So you just look at
and 1.
So you just look at your summations from each of the 3 adders, and that's your answer.
Yes. Yes.
Perfect.
Yes.
I like it.
Now let's convert this into VHDL. In this VHDL, what I'm gonna do is I am gonna make one full adder. One full adder. I'm gonna build one full adder, okay? And I'm gonna use it 4 times, 8 times, 16 times. It depends on the size of or the number of bits that I'm gonna be adding together. So one full adder, I'm gonna make a file. This file, it is full adder, entity, full adder, X, Y, and C in, those my input, sum and C out, those will be my outputs. Architecture, I called it behavioral. Full adder, the same entity name. Here, 1, 2, 3. Okay, now I go here. What is sum? Sum of full adder, it is A exclusive or B and exclusive or Cn. And this is sum. I wrote it here. Now, what is C out? C out, according to the circuit, it is A and B, or A exclusive or B, ANDed with Cn. As you can see it in here. I end this program, which I will call. I will call it, and when I call it, it will be a component. What is meant by component? This is my structure. You remember? Here I have the component. I can call this component to use it in here. I can call it 1 time, 3 times, 10 times, 20, 100, whatever the number you want to call it. I can call it. So I don't have to write it 100 times here. I wrote it 1 time as a component, and now I can call it whenever I need it. So this is my full adder. It will be in a file, separate file, and the file name will be full adder case sensitive.
Professor,
Yes.
can you go back to the VHDL? Okay, so previously we saw next to architecture that you would use synth. Would that be the component, and then behavioral is a component for the full adder?
All of this is a component. All of this is a component.
I see. So the declaration for a full adder is just behavioral now?
Forget this is the name. I am giving it a name. The name I gave it in here, I ended it here. That's it.
Okay.
Call it Vitali, no problem. Let's see. This is my structure. This is the main program. The main program. I want to build 8-bit adder. 8-bit. I will have for the 8-bit, as you can see, 8 inputs, and the smallest, the least significant bit, it will take the carry in. On the output, I have 8 outputs, and the highest significant bit, I'll take the carry out from it. In between, I am taking the output of the carry of the first, carry out of the first, it will be the carry in of the second. Carry out of the second will be carry in to the third, and so on. Can you see those red wires? Are those input or output?
These signals.
Signals,
The red wires.
internal signals.
Internal signals. Yes, those will be internal signals. And you can see here my full adder, which is to add 1 bit to 1 bit with carry. I called it 8 times. We call it is instantiated 8 times. So I have 8 instances of this full adder. Again, this is my full adder by itself. And this is the program I am writing. Here, A, it is 8-bit 7 to 0. B, 8-bit 7 to 0. S will be my output, 8 bits. The first, the smallest bit will get the carry in. It is 1 digit. And the highest bit will get the carry out. Here it says, I finished with the IEEE library. I finished with the entity. Now I'm going into the architecture. Now I have a component and component. Let's see it. My component is the other program that exists in another separate file, but under the same folder, The folder name, it is Adder8, because this is my main program. So the folder name and this file name will be Adder8. This Adder8 will call a component. This component, it is full adder. I don't bring it all in here, but what I do is I am saying to my architecture, which is behavioral of Adder8, this component, it will have those input and output. Those input and output. Those my input and output. You may just copy from here, paste in this component. You copy the port as it is. This is my port. I copy the port. Okay. Now I go to my main program. As you all said, C will be a signal, and I will have how many signal lines? If I count 1, 2, 3, 4, 5, 6, 7. Why not 8? Because C in here, this is a real signal, and C out here, it is a real signal. So I need only 7. So this is my signal, C. Now I go begin my architecture. Full adder 0. It is going to call the full adder component and the port map. What is the port map? I have here the full adder. It has X, Y, C in, some, C out. But I have here my inputs. My inputs A, B, C in. How the full adder is related to my real physical input. The first one will take A0, B0, and will take C in. And it will give you some 0 and C out. This will be C1. That is how I relate my component to the left to my real data. Now, full adder will execute and bring me the data back. Now I go to the second stage. It will take A1, B1, C1, S1. What is C in? Can you see C in? It is the signal here from the previous stage. And I will get C2. It will be the C in of the following stage. I repeat that 8 times. End behavior. That's the end of my program. For this one, your last task of the homework is to do this program. And please note your input and output. When you go to the waveform generator, you need A. It will have 8 inputs. B, will have another 8 inputs. C in, this is 1. 7 plus 7 plus 1, we have 15. What about the output? I have 8 summation plus 1 final carry. So I will have 9. So 15 in, 9 out. That is what you should see. Those are the tips that you should observe. As I said, entity name must always be the file name. Architecture must be the same in all modules, files. Behavioral. Project name must be the same as the main entity name and the same as the folder name. Just a moment, please. Yes.
Hello, Professor.
Any questions, guys? Any questions? Our full adder. Is there anything that is not clear?
Professor, just a general question.
Yeah.
So let's say I'm going to start a VHDL project to make my 8-bit adder. And I have a folder on my desktop and it's under EE331 under homework 1. Does the folder in which I save my VHDL file in, does it also have to be called adder 8?
Yes.
Okay, sounds good. Thank you.
Make another subfolder. Yes.
Okay, I see. Perfect.
Any
I think
other
Jose.
questions?
I think Jose had a question, but I'm not sure where he went.
No, I was just looking to see if you were still here.
Okay. If no questions, we'll meet Monday then. And I believe you should be done with this assignment and we are ready to go to another topic. Okay?
Awesome. Thank you, Professor. Have a good weekend.
You too. I wish you all great weekend. Thank you. Bye-bye.
Bye-bye.
Thank you, Professor. Have a great weekend.
You too. Bye-bye. Thank you.